Hi, welcome to the chemistry edition of Darling Fees channel. My name is X-Coco and I am delighted to present to you Mole Concept Calculations Part 3. In this lesson, we will look at density or mass concentration calculation, which has the symbol P here. Then also we'll look at molarity, which has a symbol B. Now let's start with the formulas. So mass concentration here, which is P, is equal to mass over volume. Take note of this. Mass concentration has the unit grams per dm cube, or we can also say grams per liter, because 1 liter is equal to 1 dm cube. But we also know that mass is equal to N times M. That is, when you make mass the subject from N equals mass over molar mass. This is what you get. So in place of this mass, we can insert N times big M. So P here will be equal to N times big M over volume. But let us look at something here. N over V is equal to concentration. So N over V is equal to concentration. So in place of N over V here, we can insert what? Concentration. So P becomes C times M. That is, P is equal to concentration times the molar mass. So C here will be equal to P over M. That is when you make C the subject from this equation. So these are the formulas that we'll be using in this section. Now let's look at the first question. The question reads, what is the density of a solution of CaCl2 whose concentration is 0.96 mole per dm cube? So in this question, we have concentration given to us, that is our C. From this compound here, we can also determine the molar mass. So we revisit the formula and you will see that we'll be able to use P is equal to C times M here. So P here is equal to the concentration, which is 0.96 times the molar mass. That is what we have obtained from here. That is Ca plus 2 times Cl, which is 40 plus 2 times 35.5, which is equal to 111 grams per mole. So finally, we'll get 106.56 grams per dm cube. Without the unit, it is incorrect. Now, let us look at the second question here. This is on a hydrated salt. So, hydrated salt Na2CO3.X water has a concentration of 0.02 molar and a density of 5.72 grams per dm cube. We are to find for the value of X. Atomic masses have been given, which is Na23, carbon 12, O 16, and H equals 1. So how do we solve this? Looking at the question here, we have something that we can get from this figure here by considering the unit. The unit here is grams per dm cube. And we know that if it is grams per dm cube, that is for density concentration or mass concentration. So we know of P. From here too, we have our concentration, which is C. So we can say M molar mass is equal to P over C. That is using the formula P is equal to C times M. So when you make molar mass the subject, that is what you get. So we insert the figures and we are getting the molar mass to be equal to 286 grams per mole. Now what do? We are dealing with this compound here, and we know that if you are to solve for molar mass, it is the molar mass which is equated to this compound. So we have molar mass of this compound to be equal to 2 here times Na plus carbon plus 3 times oxygen plus x times 2 times 8 plus 16. Now with this one, you always get 18. So that will be x times 18. So that is what we have done here after inserting the atomic mass. So we have 2 times 23 plus the 12 for carbon, 3 times 16 plus 18x. So the molar mass is now equal to 106 plus x. But take note of this. This is capital M is equal to what we have here. We cannot solve for two unknowns. So what we will do is we go back to the molar mass which is obtained from the question and insert that here. So we now have 2a6 to be equal to 106 plus 18x. So after subtracting, you will get 18x to be equal to 180. Therefore, x is equal to 10. So rewriting the chemical formula here, we have Na2CO3.10 water. That is a nice try. Now let's look at molarity. Please take note of the definition because we'll be taking note of something here. It is the amount of substance in moles dissolved in 1 kg mass of solvent. Please take note of this. It is 1 kg mass of solvent. So it can be water, it can be any solvent, meaning that the mass of that solvent should be in kg, that is kilograms. The symbol is B and the unit is mole per kg or small m. Please, this small m here is not mass, that is for molarity. All right, so let's start with something here. We have molarity to be equal to the moles over the mass of the solvent, which is supposed to be in kg. Take note of that. All the formulas that we have considered so far is applicable depending on the nature of the question. Now let's look at this question here. We have 2 grams of silver trioxynitrate, that is AgNO3, which is dissolved in 100 grams of water. What is the molar concentration of this solution? Now let us deduce from this question. In this question, we have the mass of AgNO3, that is 2 grams. Do we know that of the solvent? Yes, we have the mass of the solvent given, which is 100 grams here, meaning that we have to convert the mass of this solvent to kg, that is by dividing by 1000. Now looking at the formula, it is B is equal to N over mass in kg. Now from here, we don't know the moles, that is small n. So what do we do? Using the formula N is equal to mass over molar mass, we can get our mole. So we have the mass, which is 2 grams, which is in the question. Then molar mass, which is also given over here, that is 170. So it is 2 over 170, which is equal to 0.0118 mole. Take note of that. So finally, we move to our molarity, which is B is equal to N over M in kg. So we have the mole, which is obtained from here. It is 0.0118 divided by 0.1. Why 0.1? We said that this mass here is supposed to be in kg. So we divide this 100 gram by 1000 and that will give you 0.1. So we have molarity to be equal to 0.118 mole per kg, or we can say 0.118 m. Now let us look at the second question. It reads, a solution of iodine, I2, in carbon tetrachloride, that is CCl4, is used when iodine is needed for certain chemical tests. How much iodine must be added to prepare a 0.480 mole per kg solution of iodine in CCl4 if 100 grams of CCl4 is used. So in this question, we have to know the solvent and we have to know the substance involved. So let's go through the question again, looking at the parameters given. The question says how much iodine must be added. How much? Now looking at this, we have been given the molarity. Why molarity? Because the unit attached to this figure here is mole per kg. How can we determine the solvent? The question said something that we can take from here. That is 100 grams of CCl4. So it tells you that the 100 grams here is the mass of the solvent. So CCl4 is acting as the solvent. Alright, so we have molarity to be equal to 0.480 mole per kg, and that is for I2, iodine. The mass of solvent is also equal to 100 grams, for which we have to convert to kg. Alright, let's move on. We have I, which is also giving us 126.5. So we can say that B here, which is molarity, is equal to the number of moles over mass in kg. So 0.480 m is equal to, this symbol is for molarity, is equal to n over 0.1 kg. So finally, the amount or the moles is equal to 0.1 times 0.480, which will give us 0.048 mole. But the question here didn't say we should calculate the mole of I2. The question said we have to calculate the mass. That is how much. So we need mass. But we also know that mass is equal to N times big M. So the N here obtained times the molar mass here. How did we get 253? Now let's go back. Iodine was giving us 126.5, but iodine is I2, so that figure times 2 will give you 253. And finally we have 12.144 grams as the answer. Kindly subscribe to this channel and share.